Hi, this is the last lesson in the Chapter 12 shaft design. It's going to culminate with us finishing the assignment for Chapter 12. This is the lesson number 3 presentation. You'll find it in Blackboard. Lesson 3 presentation also reiterates your objectives. We talked about those in the last 2 lessons. And let's talk about the assignment for Chapter 12. Again, here is the assignment definition. This is the diagram that goes along with it. As you can see, we have a flat belt pulley at point A, which is applying torque to the shaft, or horsepower. We have a gear pair, a spur gear pair at point C, subtracting horsepower from the shaft. And we also have a 6-inch chain sprocket at point D, subtracting some more horsepower from the shaft. And then we have bearings at points B and E. Okay, so for lesson 1, you work problem 12.2, finding the shaft torque and forces due to the driving gear Q. That's driven gear Q. For lesson 2, we completed problem 12.12. Also, you calculated the power delivered to the shaft by the flat belt pulley at point A. Here's a hint. The shaft receives 10 horsepower at position A. It delivers 6 horsepower to the spur gear at position C, and it also delivers 4 horsepower to the chain sprocket at position D. So now we are ready to complete the assignment for Chapter 12. Okay, so I want to talk about power distribution first. Okay, so this is what we talked about before. So the shaft delivers 6 horsepower to the gear drive and 4 horsepower to the chain drive. And then how much power is coming from the flat belt pulley? Obviously, it's 10. So I wanted you to compute the shaft torque from the flat belt pulley and the bending forces on the shaft. Okay, so let's talk about the torque distribution. This was on sheet 2 of your assignment sheet. And what I want you to think of is that torque distribution is kind of like a equilibrium problem. Okay, so what we have here is we have 3,150 pound-inches delivered to the shaft at point A. And then from that, we're subtracting at point C, due to the gear pair, 1,890 inch-pounds. Okay, and then we're subtracting another 1260. Okay, so at the beginning of the shaft, we have our highest torque, and then from point A to point C, we have a torque in the shaft of 3,150 pound-inches. And then from point C to point E, we have a 1,260 pound-inches of shaft torque. Okay, so this is what I wanted you to do. Draw this torque diagram on sheet 2. Okay, so next what we're going to do is complete the assignment. We're going to calculate the reaction forces at the shaft bearing locations B and E in both the horizontal and vertical directions, and then we're going to draw the shear and bending moment diagrams in both of those directions. Okay, so what you're looking at here is the solution to this problem. So the first thing we're going to do is we're going to find the reaction forces at the bearings. Okay, so here is the load diagram that I started to draw. Okay, in the horizontal plane, it's fairly easy because we only have one bending load, and that was due to the tangential forces from the gear pair. Now, based on that bending load, we're going to calculate the reactions at point B and E. To do that, I chose to sum moments about point B and then solve for the reaction at E, which is 113.4 pounds. Next, I was going to sum the forces in the horizontal direction to calculate what the reaction is at point B. Okay, so then I'm going to draw my shear and bending moment diagrams. That's what you're seeing here. Okay, and then finally I'm going to calculate the bending moments. So from point B to C, I calculate the area. And what that is, this is that 264.6 pounds multiplied by the 6 inches right here, 6 inches on the shaft. So when I multiply that 2, that gives me the area under the shear curve, which becomes my slope for the moment. Okay, so that means the moment at point C is 1,588 inch-pounds. And then from C to E, then I have a negative 1,588, and then that concludes my shear and bending moment diagram for the horizontal plane. Now what I'm going to do is switch to the vertical plane. Now see, I have more loads in the vertical plane here because I have loads from the flat belt pulley coming in. That's the 630 pounds you calculated in the second lesson. And then we have the load, the tangential load from the spur, well, this is the radial load from the spur gear pair. And then we're also going to have the load from the chain sprocket. And again, I'm going to go through and calculate what my reaction forces are. I did it the same way. I sum moments at B to get my reaction at E, and then I sum forces in the vertical direction to get my reaction at B. I draw my shear diagram like this, and then I calculated the bending moments as you've seen here. Okay, so this concludes this presentation. What I want you to do is finish filling out the 3 sheets of assignment chapter 12 and placing them in the drop box. Thank you.